sorry, I need to use, okay.
Yes, for the recording.
Okay.
Yeah.
Oh, wow, okay.
By the way, I will be the timekeeper at the back, so there's like 10 minutes
Okay.
left and stuff. I will give you a sign, okay?
All right, okay. Can you help me with the, yeah.
Do you need help?
Well, let's see. There's a control here. Here it is. Sorry?
I think it's already.
Oh, I can see it coming up, yeah. Okay, so should we just test this? Okay.
It's already on, so you
Okay.
just have to put it on.
All right. All right. Who's doing the recording? No? Nobody? Okay. So, hey everybody. I thought we had a lot more people signed up for this workshop. I guess a lot of the people are still having their lunch, right? What's the plan? Okay. But we don't have a lot of time, so we can't wait forever. Don't. I'm sorry. Okay. Okay. So, oh, sorry. All right. So if I do this, woohoo! Okay, it works. So hey everybody, good afternoon. Welcome to our workshop, which is called "The Robots Are Coming," which sounds kind of exciting, but it's probably not really as exciting as it sounds, because, well, we came by Air Asia, right? So we were kind of limited with the stuff that we could bring with us yesterday. So instead of bringing our big robots, we just brought some teeny tiny robots for us to experiment with for this workshop. But I brought my assistant, my colleague Lila, who will be helping out as well and trying to get you, encouraging you to work on a few things. And my name is Colin. Basically, I'm my background is a software engineer. So I started out as a software engineer, and basically I've become, somewhere along the way, someone who teaches other people about being software engineers. So now we present training courses about programming languages, about programming practices, all kinds of things like that, right? So this is an advert, right? So the reason I'm doing this workshop is I was at another Pycon conference a few months ago. And at the end of the conference, someone stood up and they were giving feedback about the conference. And they said, well, this was awesome, but what we really wanted was some more workshops for beginners as well. So I thought, oh, okay, maybe I'll do something like that. So we made a submission and it was accepted. So this is a kind of beginner level workshop. So if you are already a hardcore Python coder, you might find some of this stuff a little bit basic, but I hope that you will at least have some fun playing around with that little robots, right? So that's the plan. So what I want to do is just spend a few minutes just talking about the robots that we have and the activities that we have. And then basically I'm going to just get you to try some stuff out, right? And I have a few challenges. That's why we have these things on the floor down here. A few challenges for you to try out and to see what you can get our little robots to do, right? So that's my plan for this workshop. Does that sound all right? Okay. So I have a couple of things that we need to do to begin with. So, oh, okay, hang on. Do I need to do this? Yes. So there are a couple of documents that you need to grab first of all. First one, there is a PDF. That is a kind of little workbook, the little book of challenges that go along with this workshop. So you'll need to grab that. It has the instructions in for how to download code to the robots, that kind of thing, right? Second one is the little robots that we have. These are our commercial kits, right? We didn't design or make these ourselves. And there is a function library that you need to use Python with these little robots. So you need to grab a copy of that library. So I've just made a link to that function library as well. So you need to download it onto your machine, extract the files, and there are lots of files in the zip file that you get, but you only need one of them. There is a program file called cutebot.py. These are called cutebots. So that is the one file that you need for our code this afternoon. And we are going to be using MicroPython. So we're going to use the online MicroPython editor. So you just need to make sure that you can open that editor, okay? So the URL is just python.microbit.org, and it should take you into the Python, MicroPython editor. And I'll show you how to use the MicroPython editor in a moment. So if you haven't already got these things, just maybe take a picture of these URLs so I can move on in the slideshow. But of course, you know, if you need to ask or need to see them again, then please just say so, right? And we can always go back over things. Oh, and as it says over here on the right, these URLs, these short links, they are case sensitive, right? So you have to be careful with the uppercase and lowercase characters. If you have any problems, just give me or Lila a shout, and we'll try to work any problems out, right? I can't see a thing here. Okay, so I want to just say a little bit about these little robots that we have here. Well, there's one. The robots are powered by these tiny devices. So this is a BBC microbit, a BBC microbit microcontroller. So maybe you've heard of these things, right? They are very commonly used in schools. They were designed in the UK for use in computing education, things like that. You can program them with MicroPython. So MicroPython is Python, but it is a version of Python that is kind of cut down so that it fits into the tiny amount of memory that is on a tiny microcontroller like this, right? You might have heard of other similar microcontrollers. Things like Raspberry Pi Pico, for example, is also a similar kind of microcontroller. And you have probably also heard of Arduinos. Arduino is also a kind of microcontroller, but with Arduino, usually you program them in C, right? But with BBC Microbit, the native language is Python, or MicroPython. So MicroPython allows us to use Python, even though we have a teeny tiny device with a teeny tiny amount of memory and a teeny tiny processor. Actually, these are really powerful little devices. They have an ARM Cortex processor on them. So they are actually quite powerful little things. But it allows us to use Python on a little device that can be powered by USB or powered by batteries. So people use these in all kinds of electronics projects. You could even do things like make wearable devices, right? They are so light and small, and they only require a couple of batteries to power them. And they are also very popular for making little robots, right? So this is a microbit. So can you see? It's the same. The front and the back. Who's used one of these before? Okay. So this is the front. And you can see that it has two little buttons on it, A and B. And these little things, this is a grid of LEDs. So when your program is running, you can make text scroll across on the LEDs, or you can make a little face, a little picture on it, right? So it's got a 5x5 grid of LEDs. So pretty neat little thing. And on the other side, that's this side, it's got lots of little bits built into it. It's got a teeny tiny speaker built into it. It has an accelerometer built into it. So you can write programs where you can shake the thing, and it does something based on you shaking it, right? So you can maybe shake it and make a sound, or do something like that. And it also has a microphone, and there's a USB port. It even has Wi-Fi and Bluetooth built into it as well. So super powerful little devices. I'm not here to sell these things, by the way. I just like them. I just like it as a little device, right? So that is a BBC microbit. So it's a commercial device. Anyone could buy them, but they were designed for use in education, right? And they are used by people doing electronics as a hobby. And the other thing that we have is this little robot. And again, this is a commercial kit. So we didn't design or make these ourselves, but they are just simple little wheeled robots, and they have the microbit as the kind of brains of the robot, right? And also on the robot, you can see this is the top of the robot. That's that. It's got battery pack, so the whole thing is just powered by 3 batteries. It has 2 motors, so it has 2 wheels, 1 motor for each wheel. And it has some headlights, so some LEDs on the front. And there is a kind of expansion socket. The picture doesn't really show it very clearly, but there is a little expansion socket in the front, which has currently got this little eyes thing that's plugged into it. It's an ultrasonic sensor. So that is the top of the robot. And underneath, it has got, at the front here, 2 line tracking sensors. So these are sensors that are basically, they can tell the difference between black and white. So some sensors you can use to detect different colors, but these can only really detect black and white, right? So they can tell when they are on a line, for example, so they can move around and follow a line. In industry, when you have industrial robots, often when you see robots in factories and things like that, like robots that are used for packing things in factories, they often also follow lines, right? So although this is a very common thing for people doing robots as a hobby to do, people have competitions where they have, see who can make the fastest line following robot, right? It is also something that does have an application in industry as well. So if you Google line following robot, you can see in factories and things like that, things like places where they make cars and so on, robots that follow lines, right? So this has 2, it's not really clear again, but it has 2 line tracking sensors on the robot. So really cool little robot kits. So with the BBC microbit and the robot kit, oh, and I'll just point out the sensor at the front here. This is a distance sensor. So the way this works is, it looks like 2 eyes, but it is a kind of ultrasonic sensor. So it works in the same way as a bat detects its prey. So the way it works is, one eye shoots out a kind of ultrasonic pulse. And when that hits something, it bounces off and then returns to the other eye, right? So it goes do-do-do, out one eye, do-do-do, back into the other eye. And the amount of time that takes, of course, is longer or shorter depending on how far away you are from the actual obstacle, the object, right? So if I'm far away, the time is longer. If I'm close to it, it goes do-do like that, and the time is really short, right? So you can use that time to calculate the distance you are from an obstacle. And if you know how far you are away from an obstacle, you can do something with your robot. So if I go towards an obstacle, find, there's something there, I can turn, go another direction. There's something there, I can turn, go another direction. There's something there, I can turn, go another direction, right? So these are not really perfect. They are not super reliable or anything like that, but they are perfectly fine for little hobby robots, right? And for experimenting with and doing a bit of programming. So altogether, we have a robot with a processor, motors, wheels, line sensors underneath, a distance sensor on top, and 2 lights as well, so 2 headlights on the robot. So pretty cool little thing for playing around with and experimenting, learning a bit about MicroPython, learning a bit about Python programming, things like loops and sensors and using sensors and libraries and things like that. So that's what we're going to use for our little workshop. So these are the steps for programming the robot. They have a USB port on the top. So you just need a USB cable, standard micro USB cable. You need that function library that I mentioned at the beginning. And there is a file in there called cutebots.py. And you need to add that to your project. So just like adding another file to a project. And that gives you access to the functions of the robot. And you write your code. So we're going to use that online editor for our activities. If you did have another editor like Visual Studio Code, for example, you can also use that, but that requires some extra setup, some extensions and things. So I think for today, it's just easier to use the online editor, right? So you write your code and you save it, and it saves onto your computer. And it's saved into a kind of binary file format called a hex file. That goes into your downloads folder on your machine. So I guess if, it depends on what operating system you are using. So if you're using, I guess, Windows or a Mac or Linux, you always have a downloads folder, right? And it goes into that folder. You plug in the robot, the microbit. That appears as a kind of external drive. And then basically, you just drag and drop. So you drag from the downloads folder over to that external drive, and the file gets copied over to the robot. When you are using a microcontroller, the difference between a microcontroller and the processors we have in our PCs, microcontrollers have everything built on to the chip itself. So this teeny tiny chip has the CPU, the storage, the input and output, everything is on here. They are usually very slow compared to our laptops, but they also have very low power requirements, right? So we can power the microcontroller with some AAA batteries. We don't need a massive battery pack inside the laptop. And usually they run one program at a time, right? So when you copy a program over to the microbit, that becomes the program running on the microbit, right? So you just have one program running on here. So you copy over a hex file, and that becomes the program that runs on the machine. So I'll show how to do that in a second. But I also just want to show the activities that I want to try out this afternoon. So these are the things we want to try with our little robots. Number one, switch the headlights on, because we need to see where we're going, right? So we'll try out thinking, make sure we can get the headlights to work. These are little snippets of the kind of code that we will use. So, of course, when you get that function library, you need to import it into your main Python program. So this is in your main.py. So the project that you use has a main.py. That's the main program, and then you can add other files to it as well. So you import that function library. You need to create a variable for the robot. So where it says CT equals CuteBot, that kind of constructs a variable called CT, which is of type CuteBot. And that gives you access to all the functionality of the robot. So the headlights, the motors, the sensors, the line sensors underneath, things like that, right? And basically, this is how we switch the lights on. So CT dot set car light. It's got two lights, a left light and a right light. And this is an RGB value, so red, green, blue. So 25500 would be pure red, right? It'll be the brightest red that it can be. If you use other values, if you put, say, 128, 128, 128, that's like half red, half green, half blue, and you get a kind of gray light. Or you can put, say, 0, 2550, and it will be a pure green light. So you can choose the red, green, and blue settings from 0 to 255 of how intense you want the colors to be of the LEDs. So that is a snippet of code for controlling the lights. We can also set the speed of the motors. So, oh, incidentally, these functions which I have here, they are also in the PDF that I gave you the link for as well. So set motor speed sets the speed of the motors to a percentage of its highest value. So if you want to move the robot forwards, it has two motors, you set the percentage of both to being some value, right? So 50-50 sets both motors to 50%, so the robot will move both motors forward. If you put 100-100, it'll be zip, and the fastest the robot can go, 100% maximum speed, right? If you put the two values as two different values, the robot will turn. So if I put, say, one at 50, one at 20, this robot's moving forward at 20%. This motor is moving forward at 50%, so the robot will kind of turn around, right? If I did the other way around, say 20, 50, it will turn around that way around. If you put one motor into reverse and one motor forward, you kind of go zip like that, and the robot turns on the spot. So if I say minus 50, 50, one motor goes backwards at 50%, one motor goes forwards at 50%, and it kind of turns around on the spot, right? So it kind of does a right angle turn. So we can control the motors by setting the motor speed. So if we wanted to follow a line, then if we know we are on the line, we go straight forward. If we know we are kind of going off the line, then we kind of need to turn back, right? So if I'm going like this and I'm going, uh-oh, going off the line a bit, you turn back the other way, right? And that way the robot stays on the line. If you want to get the value of the line sensor, there's also a function for that as well. So get tracking is the command. If you get back 0, 0, it means that both of the sensors are reading white. If you get back 1, 0, it means one sensor is reading black, the other sensor is reading white. If you get 0, 1, it means this sensor is reading white, this sensor is reading black. And if you get 1, 1, that means both sensors are reading black, right? So that can tell you if you're on a line or off a line. So if you wanted to do something like make sure you're on a line and keep on the line, you can use that get tracking command together with set motor speed, right? So you can say if the get tracking is 1, 1, great, let's both go forwards. If the tracking is 1, 0, uh-oh, that means we need to turn. So we do set motor speed of 1, different to the set motor speed of the other, right? Until we are back on 1, 1 again. So by that way, we can create something that follows a line. And the last little snippet of code I want to mention is the sensor, the distance sensor, has a function called getDistance, and this will tell you how far away you are from an object. So if I'm driving, and I do getDistance, my getDistance is, say, 50, that means I'm 50 centimeters away from a nearest object. Probably safe to go ahead. But if I'm driving, and I say getDistance, and my distance is 5, that probably means I need to turn, right? Otherwise, I'm going to hit the obstacle. So again, I can use getDistance together with setMotorSpeed and use a if statement to say, okay, if I'm 20 centimeters away, keep going. If I'm 5 centimeters away, stop, turn, and then go ahead again, right? So with all of these things together, we can make a robot that follows a line, detects obstacles, and moves around, right? It becomes a kind of independent little robot that we can move around on the floor. So a pretty neat little thing. So basically, that is my challenge for you. So when I'm finished talking, I'll just show one example in a moment. And then I'm basically going to say, okay, here's some robots. Grab a robot, grab a power cable. I only have 6 of these, right? That's all I could fit into my laptop bag. So you're going to have to kind of work together, right? So maybe we can kind of divide people into groups. Maybe Lila can help me with this a little bit as well. We can divide people up, and you can kind of share one. One person writes some code while another person is trying something out, right? And then you put the robot on the floor. I'll just also point out on the back, there is a power switch. So when you download the code to the robot, make sure the power switch is off. Otherwise, you'll probably download it, and then your robot will scoot off and, and run off the edge of the table, and then run off into a corner or something like that. So start with the power switch off, and then when you are ready, switch it on, and then the robot starts driving, right? So I'll just show one example of what I mean by all of this. So if I do this, oh, hang on. Where's my mouse pointer? Oh, I don't want to show that just yet. Display settings. Duplicate. Oh, okay, that looks all right. Does that look all right? All right. I'm going to go to python.microbit.org. Oh, I need to be back online. Oh, you need internet access for this. That one. Okay, let's try that again. So this is the microbit editor. So it's a pretty simple Python editor, but it's perfectly okay for what we want to do, right? So I already have that function library on my machine. So here's my steps that I need to do. Down here on the left, you can see there is something that says project, and it has a main.py, so the main Python program. And I'm going to go down here to open, and I'm going to add cutebot.py. And when you do this, notice that it says here, this is one thing to be careful of because I always make this mistake. It says change files, replace main code with cutebot.py. I don't want to do that. I want to add cutebot.py to my project. So on my icon over here on the right, I'm going to pick add file cutebot.py and then pick confirm. And then that gets added to my project. And if now I type something like from cutebot import star, that gives me access to the robot. So if I type ct equals cutebot, now I've got a variable which is my robot, right? So it gives me access to the robot's functions. When you use a microcontroller, usually you want the program to keep running, right? So you want the program to keep looping around and looping around and looping around. So usually when you have a microcontroller program like this, it usually has an infinite loop inside it. So usually in programming, infinite loops is something we have to be careful about, right? It's not always a good idea to have infinite loops. But when we want to do this, we do want to have an infinite loop. So how do we create an infinite loop in Python? We say while true, because true is always true. So the loop will always loop around and around and around. Remember what I said, this is micro Python I'm programming in here now, but micro Python is just Python. But it's got kind of a kind of limited set of libraries and things with it. So it will run on the tiny device. Is everything all right? Oh, I see. Okay, we've got the other projector on as well. Excellent. So if I do something like CT dot, you can see those functions which I mentioned about the robot, right? So I've got get distance, get tracking. So if I do CT dot set motor speed, and I do something like let's say 20, 50. So I set the speed of one motor to 20 and the other motor to 50. That will just set the speed of the motors, right? So what will happen here is with one motor to 20, one motor to 50, the robot will always just keep turning and turning and turning. So basically, I've now got a program that will make my robot run around in a circle, right? So that's pretty much it. Oh, the editor is kind of smart, though. If I do make something like a typo or something like that, notice that it does highlight my errors, right? So it highlights things like syntax errors inside the editor. So my next step is I'm going to save this. Oh, give my program a name, so I'll just call it CuteBot. And that goes into my downloads folder, and it's called cutebot.hex. I hope I don't have anything weird in my downloads folder, huh? This will be a bad time to find that out. But if I go up here and I go to downloads, and I look in that folder, oh man, do I have anything in there? Well, it's all pictures of my cats. So, so get my robot. Plug in one end, plug in the other end. So the thing can be powered by USB. So you can see that it's come up as a removable drive, right? So this is my removable drive over here, and this is my downloads folder over here. I just need to, hopefully, drag it across. And what I will say is, this is not 100% reliable. I have found that sometimes this fails. But if it does fail, just try it again, right? And it will, maybe a couple of times, it will work successfully. So, okay, there it is. And I currently have the power switched off on my robot, which is good, because if I put it on the floor, switch it on, it runs around in a circle. Fantastic. I'm glad you're all easily impressed by this. Okay, so I don't want to talk anymore. I want you to try some things out now. So this document that I gave you the link for has got, the first one is trying the lights out, right? This is a kind of hello world program, just to make sure that you can talk to the robot and try out a few commands. Then, moving the robot around, and then following a line. So see if you can get the robot to follow. Now, I did have one of these already programmed to follow a line, but now I can't remember which one it is. So you have to imagine following around the map on the floor, right? And then we'll see how far we get. But also, if you are a super Python expert, see if you can also do the part about avoiding obstacles, right? I'm going to make a little maze on the floor down here for you to try that out. So, what do we think? Everything okay at this point? Any questions or anything? Everything okay? Yeah.
create our should we create our line, or anything in the floor that looks like a line can be followed by the robot?
Yeah,
For example,
so,
in our
like
floor.
for example, the gap in between the tiles, I guess it would probably read that as black, right?
I
It
see.
can only read
black and white.
it only reads black and white. These are only line sensors. They're not color sensors. So anything that looks like a black line, anything that looks like it's not a black line, that will do, the sensor will just tell the difference between
So
those
if we
things.
change the color from black to gray, let's say, it will be
Gray, I guess you would have to experiment a little bit, right, to see how gray it can be before it says, okay, this is black, or okay, this is white. Maybe if it was like really light gray, then it would register as white, but if it was dark gray, it would register as black. There is a boundary somewhere, right, between what is white and what is black on the sensor. Hey.
coloring the product using black light or white light.
I'm sorry?
Coloring the product using.
So in the book, I have put some cheats. There is a cheat sheet. If you go to the end of the document, there is a section called sample code. And there is a section called line following. And maybe if I make that a little bit wider. CT get tracking is the function for saying which of the two sensors is a black and white, right? So like I said, if it's black, it means you're on a line, keep going forwards. If it is black, white, you're off the line, turn one way. If it is white, black, you're off the line, turn the other way, right? So that is the way that you can turn corners with your robot. Oh, and I would also just say the motors in the robots, they are not perfect, right? They are just simple DC motors. You might find that some of the robots are a little bit faster than others, but see how fast you can get it to go and still follow reliably the line, right? You can make it go a bit faster than this that I have here. So, anything else? Okay, so, Lila, can you help me out with this part? I have six robots, and I have 12 power cables.
This is the boring part, right?
That was already the boring part.
Right? So can I have all of you group turn the tables around the front one, make it into like a group of 6. I think 6 or 7, I'm not sure. New people are just joined in, right? So jadikan group 6-7 orang satu group. Okay? Is there any part yang boleh cakap you nak I translate? So are we good?
Yeah,
Right?
yeah.
Okay.
Okay, so I'm going to give you guys one of these. You will need to kind of share. Can we turn this around a little bit? Couple of power cables.
Not going around the line.
I'll do that in a minute, yeah. Okay, maybe you can use that spare table.
Well, with Linux or
I'm sorry?
the program work well with Linux and or it just Windows?
Because it's an online editor, you can use any operating system. Yeah, you can also.
We put the program to the controller.
It has its own built-in operating system, so it is just I guess if you were a super advanced programmer, you could program the operating system of the robot, but you don't need that for today's.
You don't need to install something.
No. No. Everything is done using the online editor, and then you copy it over to the robot. So it's all kind of nothing too advanced for today. Yeah, if you had your own robot, you can do what you like, right? There are other operating systems you can install on here. So, for example, there is a robot operating system just called Robot Operating System, ROX. I think you can use that on these robots too, but for today we don't need anything too advanced like that. Can we use that spare table? Yeah. Okay. So one of those. And then can we use one of the spare tables? Okay, here we are.
Okay, so these are the 3 files that you need to kind of download, yes? What is this for? Okay.
Sorry. Hey, can we use one of these as a central table? Okay, so here we go.
Grup yang melekat belakang ni ramai sangat orang kan? Nak join grup lain? Tak nak? 1, 2, 3, 4, 5, 6, 7. Oh, that's fine, really. We have one more, right? So
Yeah.
that last group there, are they like the coordinator group or are they going to work on it? Mereka tu? I'm not sure really. That group at the end, are you all participating? Do you also need a robot?
Yeah.
Or are you just onlookers? Okay, sure. Okay. All right. That group over there, can you like come over here because there are like few more people there. So, tak adalah ramai sangat ni sampai 10 orang tu. Yang baru masuk tu. Why don't you guys move there? All right. Okay.
Oh, okay. So how are we doing for
Yeah,
groups?
the last one is there. There's two new group
Okay.
and then these people
right,
are going to
so a
join.
couple more.
Okay, so step 1, download all these files, okay? And then you follow the PDF and carry on with the steps.
Hey. So maybe we can turn this around.
You can still join, guys.
Robot. Press. Oh, okay. So who's left?
That one, that group there, the new group.
Everybody okay? One spare robot.
Colin, that group. This is one group.
There's one robot
Oh,
here.
they are. Isn't that for? Oh, okay, that's fine.
Okay.
1, 2, 3, 4, 5. Okay.
Okay, I have one spare robot if someone wants to have a private robot.
Okay, so I just want to clarify with you. So they were asking me, so they download all 3 and then follow the steps in PDF, right?
Yeah.
Okay. So we want to see which group is going to finish first, right? Okay. So as what Colin was saying, so you download all these 3 files and then the first one is like a workbook. So you follow the step, the workbook. Okay. Code dia semua dah ada dah sebenarnya.
Sorry? Yeah. So this goes in the top. Way around, that way around. Oh, sorry, that way around. What you might notice is if you have a syntax error or something like that, you might get an error, a message that appears that says error.
So please feel free to ask questions. Okay, you can call Colin anytime you're stuck or you want any questions answered. Sorry? What we need to solve is all in the PDF. Yes.
Yeah. So let me put
Yeah,
that back
look
on
at
the
the
screen.
challenges and all the things that you're supposed to do are in the PDF. Yes. Okay. So as what Colin mentioned earlier, the first step will be pretty much to turning on the lights on the robot. Okay. Step 1, get your downloading, follow the steps in the PDF, and just to remind you, the first thing is to turn on the lights of the robot. Okay. Is that the biggest you can get? It's very blurry.
On this projector, it's not very high.
So as what Colin mentioned tadi, make sure the robot switch is turned off first. Okay, before you do anything. All right.
It's all right. Cool. Okay. Already have something working.
Yeah.
Oh, okay. You already done that part.
I think you need to go and check another groups. It seems to be a bit blur.
Yeah. Let's see what these guys are going to do
Yeah.
first. Take pictures.
No.
Too fast.
Lajunya. Well, at least it's moving and it's got lights. Step 1 there, done. Okay, so that group has done with the lights of the robot. It's already turned on, okay? All right, for the rest of you.
How's it coming along? Working. Okay.
Joining, you can join that group. Oh, you're behind, okay. So any questions at all? Any clarifications? Group yang belakang tu? All girls? Not all girls. Okay.
Okay. It looks like you have a download error or something, right? You can see because you have an error code, unhappy face. Just try downloading it again. I have found that sometimes it just takes 2 or 3 goes just to download it. I don't know why. It's some combination of the operating system and the robot and who knows what else.
So if you look at the workbook, the second step after the turn on the lights is putting a smiley face on the robot.
Yeah. Project name could be anything. Yeah. Yeah.
I already copied the file.
Mm-hmm.
But I try to take.
Well, you're busy.
Dah okey dah? Belum?
Okay, well, it says it's there. Okay, yeah, the yellow light is the kind of activity light. Try it and see what happens. If it really doesn't work, try a different. Oh, sorry. Okay.
Hmm?
It should be fine.
You can
it's
join
just a
that
file,
last
right?
group
it's just
there.
dragging and dropping or copying and pasting the file.
That's sebab dia kurang orang.
But
You
when
can
it gets
join them.
finished, the file should disappear.
Yes,
right?
that
And
group.
it flashes into the robot.
This
mode.
group
Oh,
orang
okay, there
ya.
we go.
So can you all work together because
Perfect.
there's like 2 new people. All right.
Something worked. You have a program running. It says hello.
Any luck?
Oh, sorry.
Oh, the file is stuck. Okay, yeah. Colin did mention you have to try a few times.
On the back, one is just the power light. One
Cancel
is
and
when
try
you're
again, yeah.
downloading. It's like an activity light. So it shows when something is. Which one?
Ini file yang mana yang nombor 2 tadi ya? Oh, pertama tadi. Okay.
Oh, on the LEDs. All right. Let's have a look.
Their file is stuck, so they tried again. They're trying again now.
504. That is an error message. And you get an unhappy face as well. You can see. There's a sad face. Just try it. Just try it again. Try pasting it again. So I don't know why. Sometimes it takes 2 or 3 goes for it to work.
Okay, if your downloading file is stuck, please cancel and try again. So sometimes it takes 2 or 3 attempts to download. So it's nothing to do with our file. For some reason, it's been like that.
You might need to unplug and plug again. Oh, okay, it's working. It's in progress. No? Oh, you have a syntax error now. So line 42. It has something, sometimes, but you can try running it. Sometimes even when you have an error message like that, it will run. So you can try it. You don't need to. You can just unplug it and then switch on in the back. Okay, there are some lights.
I think they can pull this here because they don't have to run. You need to check on the other 2 groups, Colin. They seems to be very lost.
Okay, let's see how these guys get on first.
Oh no!
Oh, I think it's. Ya, beloknya harus seperti ini ya.
Beloknya tak betul ya? Oh no! What happened there?
So far, so good.
Okay, will you color it a bit? You mean the thing? Yeah. I think you need the marker.
If you want,
Yeah,
you
give
can
it to
do-
them. They'll do it. Yeah.
Sorry?
Yeah, you have
Yeah.
to color it.
Some-
Give it to them. Let them color it. Okay, try now. Oh no. Okay, there as well. Give them the marker.
Okay.
Give them the marker.
Oh.
Ah, okay. That's a tiny part there.
If you want, you can.
Yeah. Okay, why don't you just
try that, modify
recolor
it,
some of
but-
that? Yeah.
Okay, now I
No cheating,
turn
though.
on this.
Oh, this one, right?
Oh, wait.
Ah,
Sorry.
okay. It's not moving yet, so something must be with the code.
No, we have the lights are flashing. So that's
The
good.
lights. So first step is done. Your
But now you
lights
need
are
to-
on.
Now you need
Okay.
to move the robot.
Yeah, you need to. Well, you have to follow the steps in dalam buku, ya. Yeah. Okay.
Okay, let's see how we can. How's it going? There's your robot.
No problem. You can put it on the table. Okay, so the robot is not going to move automatically. Yeah? You have to follow the steps in the PDF, right? Challenge 1, challenge 2, and so on. Turn on the lights, put a smiley face, move forward, and so on. Bila habis semua tu baru dia akan ikut. Okay?
You're kind of a big group, so if you need someone else wants to try, then you can take the spare robot.
Yeah, they already have one robot there. Why are you giving them another one?
Because there's like loads of them, and they're not
Oh,
sharing.
okay. All right. Okay. Do you want to look at that group? I'm a bit lost.
How's it going? Is everything okay?
Come on in.
I'm good.
You can join that group. There are a few people there.
Wow.
Wow.
So maybe too fast, I think. Yeah, no, the file is kind of flashed into the memory of the microbit, so it does not appear. What you will see is you copy it across, and then when it is successfully transferred, it kind of seems to disappear, right?
Yeah.
But that is because it is in the memory of the robot now.
The file still there.
No, in a way it is, but it is flashed into the robot memory, so you don't see it as a file anymore.
So whatever the file name is, it's still transferred to the.
Yeah. You mean if you want to edit the file, you still have the hex
Sorry?
file on your own machine, so you would load that back into the editor again. So just like a normal program, you load it back into the editor.
Oh, the
Transfer the file and we want
Yeah. Because you cannot edit it
Okay.
directly on the robot.
Oh,
You have
right.
to edit it in the editor and then transfer
I
it.
think that is syntax or something. Wait 1 minute. I'll get Colin to check for you.
I think
Colin,
maybe too fast.
Colin, they have a question. They have something flashing on their robot.
Okay.
This group here. Yeah.
How's it going? Sorry? Okay, so OS error. 5, 7, 0.
Maybe something wrong.
Try running it anyway. Just try switch the robot on and see what actually happens. Switch on. So there is a power switch at the back. No. Like. I think it has got
Oh, dah
stuck.
pandai pusing. Okay.
This is the transfer. Like, try transferring it again.
No.
No, sad face. 9.
That's not supposed to face. Something wrong.
How it should be.
It should just flash the lights, like one light on, one light off. It seems that you have.
Wah, pandai robot dia. Yes.
Right.
Very good.
Oh, okay. Right. Mix the two files up. I think you might need to remove these, or just start a new project. Or remove these files and then add
Why
again.
did it reverse there? Okay, take the marker and color that part here. I think that thing is Oh, that part there.
no.
Okay, get the marker here. Here. Tengok tempat tu mungkin tidak gelap ya. Kamu boleh mana-mana kamu boleh apa ni?
Try the other one as well.
Ah.
Make sure it works on that one. Okay.
Oh, a little bit further.
on the
Color
corner.
that part there. Color with the marker.
It's because when
Probably.
it shows 00
Uh-huh.
milliwatt, right?
Yeah.
I set the problem so
Oh, you want it to turn around. Okay.
Yeah. Oh, okay. Oh no. Right, good. I think that corner is
Turn like we want.
okay.
Is this the hardware limitation or?
Probably the motors are not perfect. You know, they are just ordinary motors. But also, it's probably the program processing. So remember when you set the motors, they are always running. So if you have other commands in the program as well, and the time they are processing,
So lepas
the
ni dah
motors
boleh
are
buat
still
mock
running, right?
robo web tu
robot
ya.
has already moved. By that time, you are processing another command. So
Actually, it's just this,
you always,
isn't
when
it?
you're doing this kind of
Inside the
microcontroller type program,
robotic
you have to
mops
keep in mind
and
that the program
vacuum
is always
cleaners.
running and always moving. So possibly you may need to change the sequence of commands around a little bit, so or something like that. But also, I think maybe that corner there, you need a little bit more black.
Yeah. The line is it's not clear. I mean, the blanks are perfect. Is this you can build this yourself or you can buy this?
You can buy them, but I just did this with that pen.
use a simple alphabetic process.
I'm sorry?
I use a simple ASCII for this.
Yeah.
Can I profit with like the ID how to control?
Yes, you could. I mean, when you look at the fantastic, when you look at the people who do this in like competitions, they use like the PID type controller, like you said. But this is just a simple example. But if you want to do that, you can try it. But maybe it'll take a little bit longer than we have today.
So what they use for the program in the competition?
Well, number one, usually they would use C because C is faster, right? And also they have slightly more specialized hardware. The sensors are usually different. If you look at like a competition robot, usually they are more like a dragster. So they are more streamlined and they have the sensors like out of the front of the robot. Yeah. So it is more, let me show you.
If you're done, you can help your friends. Other groups are not done yet, right? You can help them if you want.
They look more like this. So the sensors, the line sensors are in this front part here. So the sensor is already way ahead, and then the robot turning kind of follows along behind it, right?
So was that useful for this kind of, I don't know, what is that useful?
Yeah. So if you look on,
Way more than 2 cents already.
yeah.
Those you're already done, you can help your other team members. Come
So
on.
if you look at like the competition ones on, oh come on, you're not one of the adverts right now. If you look at how fast they go in the competition,
Oh my gosh.
and look at the size pack,
So
right?
fast. Can we really do that with this robots?
No, these are more expensive.
This more. Oh.
So these are like professional style, right? You can see how fast it goes. So, but yeah, these are just like for hobby type electronics. But,
So
yeah.
in a robot competition, is it what they compete? Where they compete is with the coding things or with the hardware?
A bit of both, really. So
you
you need faster code. So someone mentioned using like a PID process. PID is proportional integral derivative. So it is a way of calculating the acceleration and deceleration of the robot.
So you're gonna know the car,
And then,
something like that?
yeah, so more like it's kind of sports car. This is like the sports car version of a robot, right? Ours is more like a.
So
a
I'm
compact
curious,
car.
all of you are students in
but
this
yeah, so that is the
university?
competition
All
style
of them,
line
all of
follower
you are students
as
in
the
this
sensors
university?
ahead of the main robot.
Oh, you're not.
So
You're
when
working.
the sensors read it, then the robot
Oh, from
is
here,
processing,
okay.
but already the sensor has moved on around to the next part. So everything affects the speed of the way the robot can follow the maze.
Are you a student as
So yeah, you
well?
can see how fast they go.
Student?
Right? But
No. So you're what is
yeah,
Bawan?
I mean, they make the mazes really complicated, like with turns and lines that go across each other
right,
and
right,
things like
okay.
that, and very tight corners and so on, to try to trick the robot into
Oh,
failing.
okay.
So it is always there's always there's competition, right, in what the robot can do. So it's really
Okay, all right.
kind of, I guess, not really a sport, but it is like a
Oh, okay,
competitive
okay,
sport.
cool. We
Yeah.
both have a
Ours is
company.
just a simple,
We
not a
do
toy,
this
but kind of just for a hobby
program. We
style
teach the
robot.
corporate
But if you
people.
wanted to do like
We do
competition,
training
you'd have
and
to
projects with
spend
the
more money
corporate
on
people on DevOps, Python, AI, IoT, and everything.
Yeah, so the
We do
sensors will be
boot
higher
camp
quality, everything will
for
be higher quality. The
corporates.
motors,
We
the
also do
motors are the
for
most
university
important part.
students. We do for any women as well.
Yeah,
for
it has
all
to
of-
be.
for everything.
Usually
Yes,
they make them kind of flat and
consultancy and training.
streamlined,
Yep.
like a sports car. But I think the motors are the most important, because some motors will allow you to do more precise control and precise turns of the robot. But these are just ordinary little motors.
Yeah, I'm recently learning about the IoT project. So there's
Oh,
some kind
okay.
of like a sensor, humidity sensor, and all of the temperature degrees.
Right.
Yeah,
Cool.
something
Are you a
like that.
student here?
No, I'm not student.
Okay.
I was back in my city.
Okay.
Yeah, it's kind of interesting because you get a code on what should you do and what's the threshold and something like that.
Cool.
Yeah.
We've done that. We do that
I
kind of.
think that one is kind of next level. You gotta know the accelerators and the speeds. And all
Yeah,
the
yeah,
philosophy. Have you ever participate on competition or maybe you?
I'm not really a competitive person, so no, no, I haven't.
Or you doing this as hobby?
Yeah.
Colin, do you want to help out that team at the end?
Sure, yeah. Okay. How you getting on?
Yeah, that last two teams are still struggling.
Okay, can you come here too? So, how's it going? Everybody okay over here? You look very puzzled by your robot. It's doing something. Okay. Okay. All right. Cool. Try driving it around on the floor. Driving it around in a circle or something like that. How's everyone getting on here? You guys are all okay over here? No, stop.
The last one.
Oops, say there. When you are ready, I saw you trying the thing, so when you are ready, you can try it. Okay. Sometimes when you are doing the distance one, it is a better idea to stop the robot, wait for 1 second maybe, and then start it again. Oh, they're going to walk on it, right? Okay, so we have 10 minutes left. See if you can get the line following working. If you want to try the distance sensor, yeah. So with the distance sensor on the front of the robot, you can try putting it in the box and see if it can find the objects.
Do you have a demo for that?
The code is in the book. I don't know. Right, well, we can show.
I think they didn't hear what you're saying.
only have all the robots are out now, so unfortunately,
Sorry.
all the robots are in use.
Okay. I think they didn't hear your announcement about that one. So you want to say those one take the challenge? Oh, it's very good. Yeah. That's great. That's very good. No.
Uh-oh.
Oh no.
Oh man, you just put Okay.
For example, when we put our pen here, it still run the.
Okay, so it's slow. I can see it is slowing down when it gets nearer. Okay. Okay.
It's okay.
Check again.
I would like you stand there. I'd like you to stand there. I'll take the whole thing.
So I guess we are running out of time a little bit. Did see a couple of people who did this successfully running around the map. If you got it to if you got it to run around successfully, bring your robot up. Let's have a look at it, and we'll see what kind of some people have got. Those people who got it working, right? So make sure your robot is set up. Come try it, and everyone can have a look and see what should happen, right?
So what's your topic about tomorrow?
I will talk about data architecture.
Okay.
He's free.
Ah, interesting.
into
Is it always compiled?
Dia tidak pasti ya.
yeah. So you can't see the gap on the phone.
Nah.
I think it might be stuck. Yeah, so it, oh wow, cool.
So it's not like regular Python, just interpreting.
Yeah, so the way it works is when you save the project on the editor, it compiles into that hex file, and the hex file is flashed into the memory of the controller. So you copy it across, it flashes it, and then that is the program that runs in the controller. So it is kind of different from regular Python a little bit, yeah. Hey, you had
Did the main file need to be main.d?
this one, sorry?
Did the main file need to be main.d?
Yes.
So you cannot create another file for.
Not with these ones, no.
So you're gonna name it main.py instead of main2.py.
Yeah, so it has to be main.py, and then you can add other files as well, like cubebot.py, but it is the main.py, which is the program which runs in the
So
memory.
you're gonna coding at that file,
Yeah.
not other files.
Yeah. So we are just about out of time. So So I have just two things to say. Number one, thank you very much for coming and spending some time here today. I hope you had a little bit of fun and trying to work out how to get the robot to follow a line. If you want to try it, just get your robot to work quickly. I saw a couple that were really good. So if you just want to show how great your robot is, just come and try it quickly and let everybody see. But yeah, thank you very much for your time. I wish we had more time to do these things, right? Because it's really cool to play with these things. I think that when you are learning a programming language like Python, being able to see something really happening is really exciting. You get things that light up or things that move around. So I think that it's a great thing. We use little robots and things in our training or for these kind of things. So yeah, so thank you very much. Also, here's an advert. if you're from a school or college or a company and you want to have some training like this for your school or your college or your company, and you think that it'll be a cool thing to do, then get in touch with us, right? So drop us an email, contact@profoundsource.co.uk. That is our company. Unfortunately, our website is kind of under maintenance at the moment. We are rebuilding it, but drop us an email and yeah, let us know if you need any work like this, any training like this. Okay. So you've still got a moment to try out your robot if you are quick, but there's another workshop coming in this room soon as well. Come to me. Hey. Okay.
Yep, obviously not.
Maybe going a little bit too fast for that. Oh, and the PDF which I gave you the link for, keep that document. If you look at the back, there is an example of the kind of code that you need for the line following and the distance sensing. Okay, so keep those links. Okay, time's up. Unfortunately. No, we have one time to do one. Oh wow, you got it working.
Wow, so steady.
Slow and steady wins the race, right? That's the old saying. So this is what you do, right? Very good. Okay, so when you are ready, if you could just make sure you switch your robot off. We will come and collect them. Just leave the cables and the robots on the table, so we'll come and pick them up in a moment, okay? So thank you very much. We hope you have a good Python conference, right? A good Pycon. Thank you. And
Thank you very much. It's been fun.